like to first of all say I would like to welcome you to the final event of Love Data Week. Thanks everyone who've engaged over this week. It has been exciting. It's been a wonderful cross-campus effort, which included Bernard Becker Libraries, Digital Intelligence and Innovation Accelerator, the Institute for Informatics, Data Science, and Biostatistics, the Office of Institutional Effectiveness, Student Technology Services, and us at WashU Libraries. Now, I know that all of the great things that have been happening during Love Data Week is going to make you really miss Love Data, so loving data with us. So make sure you reach out to us again. And if you're still excited to be engaged in something today, although it's not a part of Love Data Week, a companion event is the Douglas Day Transcribathon, which is happening all day today. And this event happens every year, and it is focused on transcribing documents from our African American collections. So more information about that is in a link that I'll share with you in just a moment. And now it is my pleasure on this last day of Love Data Week to introduce you, if you're not familiar already, but introduce you to Dr. Alvitta Ottley. She's an associate professor in computer science and engineering, and she's here at WashU with a courtesy appointment in the Department of Psychological and Brain Sciences. She uses interdisciplinary approaches to solve problems, such as how to best display information and how to design human-in-the-loop visual analytic interfaces that are more attuned to how people think. Her research supports effective decision-making in various domains, such as health communication, intelligence analysis, and scientific discovery. We're also delighted to have Dr. Ottley sit on the library's faculty council. Her talk today will focus on a concise and accurate assessment tool for measuring visualization literacy, focusing on its design, implementation, and refinement. Highlights ongoing efforts to expand the tool for more generalized and global contexts, addressing the challenges of balancing simplicity, precision, and cultural relevance. So with that, please join me in welcoming Dr. Ottley, and I am going to turn it over to her now.
Thank you, Jennifer, for the introduction, and thank you for inviting me. It's really great to see the WashU community in general just embracing data. And I saw as well that there was a competition, so I'm really excited to see who won the competition. I was trying to make sure that my students all entered as well. But so today I'm going to be talking about data visualization literacy, and this project started out in 2020, and it started from, oops, a fairly innocuous question that I got after a talk. So this was in 2020, and I was speaking to a diverse group of people. But at the end of the talk, someone asked me, graphs are used in health, politics, and other public communication, and they wanted to know, do we know if people can understand them, and is society getting better at understanding and reading data visualization? And for the first time in a long time, I was pretty stumped by a question because I did not know the answer at all. And this is something that I felt like as a community, as a academic community in data visualization, we should know this question. And it sent me down a rabbit hole. So I'm gonna pull you down the rabbit hole with me and talk to you about like how I've explored this question. I thought as well that this was a very timely question at that time because I don't know if you remember, back in 2020, there were lots of examples of misleading visualizations. So this is one of the prominent examples that was released by Georgia's Department of Public Health at the time. And here it was showing uh, COVID rates for over 15 days for five different counties in Georgia. Now, if you look very closely at this visualization, there are some odd things that are happening here. For one, you would see that typically timeline goes from left to right, and you would notice that May 2nd comes after May 6th. And similarly, April 26th also came after May 1st. So there was this weird ordering that was happening here. And this is this was an interesting example because I actually don't believe that the designer intended to be nefarious or anything like that. Because if you restructure the data in the way that you would expect it to be visualized, you do see the trend of COVID rates going down. And so this showed us that, yes, visualizations are powerful tools, but the effectiveness of a visualization is only as effective as the literacy of the people who are reading them and also the literacy of the people who are creating them. Now, visualization literacy as a concept, at least in the visualization world, is fairly new. So there isn't a standard definition of what that is, but I'll show you some of the definitions we have. So, Braun et al., they define visualization literacy as the ability to make meaning from and interpret patterns, trends, correlations, and visual representations of data. There are other people who have adopted similar definitions. So this one is from Boy et al., who published a paper in 2014, where they describe visualization literacy as the ability to use well-established data visualizations to handle information in an effective and efficient and confident manner. So here you have confidence being as a part of their definition, but there are others who recently have tried to expand this. So some people have tried to expand it into the ability to create visualizations as well. And even more recently, you see people arguing for the idea of critical thinking being a part of data visualization literacy and looking at how do you capture if someone can identify if a visualization is misleading. So, in the context of this talk, though, I'm going to focus on just the ability to read and understand visualization, because that was the main focus of the initial question I got. Can people read and understand visualization, and how do we know they're getting better? And so this idea of measuring whether or not people can read and understand visualization, again, is also isn't new. One of the first set of people who tried to explore this question was back in 2015. And this is a paper that they published. And the way they did this is they went to three different science museums in the United States, and they showed people a series of visualizations. So these are the examples that they used. And they classified them based as charts. And so charts for them are things that are more like infographic style. And they also classified a pie chart as a type of chart. And then they had some what they call graphs. And graphs here, it implies that there is some axes that is representing the data. They also had some network visualizations and some maps. But what they did is they showed uh, people who were in their museums these charts and they asked them some questions. So, one question they asked is, does this type of presentation look familiar to you? So, they were trying to understand which visualizations are most familiar. So, here in this chart, blue represents yes, it's familiar, and red represents no, it's not familiar. The dark blue areas is from the youth, so people who are 18 or younger, and then the light blue it represents, or the light colors represents the adults that they surveyed. As you would expect, adults were generally, so this is like the longer the blue, adults were generally more familiar with visualizations, But you saw a trend where there are some types of visualizations that were really unfamiliar. And particularly, they found that network visualizations were unfamiliar to lots of folks. Uh, you also see like graphs. So this is like bar charts and stuff like that. 41% of the youth population were not familiar at all with bar charts, which was actually pretty surprising for me because I expected that to be a part of education. They also wanted to get a better understanding of where they have seen images. So the most prominent place, at least for the youth population, where they saw images were in school, and that is somewhat expected. But in the adult population, you saw that they tended to see it at at work or everyday life, so weather forecasts, and they also tend to see it in news and in books. This is a fairly old study, so it would be interesting to see how these have changed over the years. So I was curious about getting some updated information, at least from the local St. Louis community. And it just so happened that at that time, I was also doing a workshop with some middle schoolers. And so what I did is I got a series of charts and I printed them out and made them into like this like tiny cards. And I had the middle school students organize them based on what was familiar to them. There were also some adult chaperones in the room as well, so we had the adults perform like the activity as well, and it was actually very, very surprising. So one of the things I noticed immediately is the students, instead of ranking them, it was better for them to categorize them based on what was familiar or unfamiliar. So we had students that are saying, these are unfamiliar, and there are things that are unfamiliar, like scatter plots, which was pretty surprising. And for this specific student, they ranked these section, and I was also pretty surprised that a map visualization of the United States was one of the lower ranked ones. And that was consistent across lots of the students there. Another trend that I saw was the line chart was the most popular. It could also be because at that time, a lot of the COVID related charts were line charts. So that just could be based on when we collected that data. But so this was like just some anecdotal evidence that maybe visualizations are not as familiar as I thought they were going to be because I thought that a lot of these visualizations were common. Uh, since I had the students, I wanted to just like show you uh, some interesting things that we found while we were doing some exercises. So another thing that I wanted to do was to see how people just think about data visualization in really authentic ways. So I presented them with this challenge where they all had M&Ms. And I told them that here's an imaginary person who really loved red M&Ms, and they think that there is a disproportionate number of red M&Ms, and the task was for them to just investigate this and see how many M&Ms are in their boxes. And what stood out to me is that students naturally started creating visualizations from just these artifacts. And so you see examples of things like bar charts, which were pretty common for them, and things like they tended to also create clusters of visualizations, which says to me that visualizations themselves are intuitive, but it was so there's a disconnect with in terms of how people intuitively think about data visualization and then also how we would display them. But the main takeaway here is it was extremely helpful to just talk to people. And so I found that the best way to know people is to just talk to them. But this also gave some supporting evidence that visualization literacy might not be as high as we think it is in the visualization research community. So from there, we started looking at how do we measure this in a more standardized way. There were at that time existing tools for measuring graph literacy. So one example is graph literacy that is typically used in medical decision making. But in the Viz academic community, we tended to use this specific test. It's called the VLAT, Visualization Literacy Assessment Test. And the way this test was created was we had a set of researchers, and the first thing they did was to survey K to 12 curriculums, and they were based in Seattle. So this is from Washington State. And so what I wanted to capture was what are the most popular charts in the educational system, because they wanted to make sure that the test that they created reflected what people are seeing. They then got visualizations from different authoring tools. So at that time, this would have been D3, which is a popular tool that we use to create bespoke visualizations. And then they also captured visualizations that are being used in the news. So from this data collection, they then selected the top 12 visualizations that they tended to see. They also did lots of rigorous exercises where they got feedback from experts in the community. And with this test, it was 12 different types of data visualization with a total of 53 different multiple choice questions with different types of tasks. So it's a pretty comprehensive test. The problem with this, though, is that when we try to think about using this test took about 22 minutes for someone to complete. And it was very, very impractical when it came to our goal of just trying to understand from a general population perspective, can people read and understand visualizations? So this meant that we decided that, we're going to just create our own tests. And we did this by just taking the existing VLAT test and then try to make a shorter version. So our goal was to create the mini VLAT. And what we went through several steps for creating this. The first thing we tried to consider was how do we balance, and recall that the VLAT had 53 questions with 7 different types of tasks for each question-ish. And so we needed to think about how do we balance the types of tasks that we want to capture and the types of visualizations that we want to capture. And like how many is enough? We arbitrarily actually chose 12 and just decided, we're going to start with just one question per chart. And then we're going to test it, evaluate it. And then if that doesn't work out, then we'll try to see if we can expand that. So this is our initial steps for creating a test that has one question, but 12 different types of charts. There are several steps that we had to go through. And I'm going to go through each one of the steps, but we had to first select the 12 items. We did some piloting, and then we tried to validate it by looking at the correlation between mini VLAT and the longer test, as well as looking to see if the test is predictive of performance. Okay. So in the first step that we had to do, we first replicated the full VLAT test. So we had 199 people from an online platform called Prolific. So this online platform, it's very similar to Amazon Mechanical Turk if you're familiar with it, but it allows us to capture data from a wide range of people. And this is typically something that we use in the research community, kind of as a response to the traditional approach of capturing data from like psych students. So traditionally when we do experiments in the academic community, we will get students from like Psych 101 to take the tests, and that doesn't necessarily generalize to the general population. And so we tend to use platforms like Prolific, which Also, some could argue it doesn't necessarily generalize because you're looking at people who are working online, people who are pretty tech savvy compared to the general population, but it is still fairly representative, more representative than university students. So we did get 199 people, 112 of them were they self they recognize themselves as females, and their age range was from 19 to 79 years. They did so with that we were able to get original scores, and then we also did a content validity where we got experts who ranked each one of the items in the original VLAT test, and they were able to rate them based on was this necessary, if it's necessary or not useful, or it is not useful at all. So from there, we were able to then select those 12 questions from the original set of 53 questions. After that, one of the things that we realized was even though we selected questions, some of the wording was kind of off. And I think this was partially because the original authors of the Villa test, like their English wasn't their first language. So some of them are where the wording were weird. And so we had people then go through and fix the wording of these original questions. And then there were also some of the questions that people struggled with. So this is an example of one of the questions people tended to struggle with. And it's showing a stacked bar chart where it is comparing exit polls for Democrat, Republicans. And some of our people who tested the test, they were not from the United States. So exit poll, they didn't know what that was. And we also were considering just political biases when we include things like Democrat and Republicans. So uh, that's an example where we replaced the data set completely and include a data set about the Olympics instead. So with all these refinements where we swapped out a data set where we thought that there could be biases involved or people didn't really understand it, and that resulted in a refined set of these 12 where the wording was refined and standardized, and the data sets were updated and chosen to be somewhat more relevant to a general audience. So, and then the next step we did was to make sure one of the things that we wanted to see is this an actual, is this a valid replacement for the full VLAT test? Would, like, in other words, would performance on the mini VLAT, is it going to be similar or that to performance on the VLAT? And so what we did was we had people take both tests, and this was in random order. Some people saw the mini VLAT first, others saw the VLAT first. We had 30 test takers, and we found a strong positive correlation between the mini VLAT test and the VLAT test, suggesting that it could be a valid replacement. Our final step to see if this test could be useful is we needed to make sure that the mini VLAT is actually predictive of performance. Like, are we actually measuring visualization literacy? Could this be predictive of performance on a separate task? And this is a standard thing that people do when they're making tests. To do that, we wanted to see if this is predictive when people learn a visualization that they're unfamiliar with. So this is a visualization, it's called the parallel coordinates. Lots of people, this is unfamiliar to lots of people. It's not a popular visualizations, but it's if you break it down, it's actually fairly straightforward once you get it. So I'm gonna like break it down for you, and I would recommend these cheat sheets for people who are not familiar with visualizations. It's visualizationcheatsheets.github.io. There's some really cool comics that break down and explain data visualizations for non-experts. But the way parallel coordinates work is you kind of like suppose you have a line not a line chart. So you have a chart with three axes. You have X, Y, and Z. And the parallel coordinates is essentially you're breaking these apart, breaking each one of the axes apart. So instead of like having them vertical, horizontal, and diagonal, you just have them all standing vertically. And what you do now, we're looking at fruits. So we want to then, you're tying a line from one axis to the other. And so each fruit in a specific data set will then create a set of polylines. And so this is the tutorial. This is a similar tutorial that people went through and they learned about parallel coordinates. And then after they're done, they answered questions about parallel coordinates. And it was meant to see how well they're able to learn a novel visualizations. So from there, again, we wanted to see, could Mini VLAT predict how well someone can learn a novel visualization? And so here's the results. On the y-axis here, we have the scores from uh, the comprehension scores after they did the test, their parallel coordinates test. And then on the x-axis here, we have the mini VLAT scores. And what we wanted to see is like a positive correlation. And that is what we found. We found a positive correlation between the test taker scores and their mini VLAT scores. So this is strong evidence that uh, both the mini VLAT is effective in terms of predicting performance, but it was also and we also saw a strong correlation between the original VLAT score, the original VLAT test, and this one. And so this gave us, so with that, we just decided to just stick with the 12 questions. These 12 questions takes about 3 minutes for people to complete overall. And so this has been a really useful tool for the past couple of years, where now we have this practical and effective test, which I've been using to collect data and document people's visualization literacy, both in the United States and across the world. But we also see this really impactful movement where now in the visualization community, as people are evaluating the effectiveness of their visualizations, they are also including visualization literacy as a covariant in their tests. So in general, so we've created this. It's now available online for people to use. We have an offline version where we have the paper version that people can print out and use maybe in a classroom. There's also an online version that people can take that is free and open to use. But I wanted to just talk a little bit about some of the things that we're doing as our next steps. So one of the things that we're very interested in looking at is using this test to compare visualization literacy around the world and also to see if we can uncover inequities, to see if there are opportunities for us to improve visualization education. So our initial steps here, we wanted to see if we can compare different countries. We initially wanted to stick with English-speaking countries, but collecting data is actually not as, was pretty difficult. So using online platforms, we first started out with South Africa, the UK, and the United States and Australia. And we did see this trend that South Africa was we saw lower visualization literacy from the South African population compared to the UK, United States, and Australia. Since then, we decided to include other countries. So we decided to get English speakers from Chile and Israel and Japan. And so now we are able to look at the overall visualization literacy scores, but then we also look at different types of charts and which ones are most effective based on the countries that we examined. And so this has now created an important tool for us to expand beyond the United States and take a more global view of visualization literacy and the disparities there. Our next steps is to look at translating this into different languages, but also we're interested in looking at globally adaptive tests. So still the original test that we have still has that map of the United States. And from our preliminary testing, particularly with our collaborators in Ghana, they wanted to have a Ghanaian map instead of a United States map. So we're looking at programmatically customizing the chart, the programmatically customizing the test based on different cultures and different country. And I wanted to end with this preliminary test that we're doing. So we wanted to not just look at visualization literacy in people, but now visualization literacy in AI. Because particularly with the popularity of things like ChatGPT, we realized that people are now using ChatGPT either to create visualizations or to help them ask questions about visualizations. And so the question that we had was, is AI actually good at reading visualizations? So this is a lot of charts, but I'm going to break it down. Here we looked at Claude, which is actually let's go with ChatGPT first. So we looked at ChatGPT, which is the one from OpenAI. Some of the original developers of OpenAI, they broke off and they started a different company. So that is Claude. And then we have Gemini, which is Google, and Llama is an open source version that I think was developed by Stanford University. So these are the four uh, different type of large language models that we compared. And then we also wanted to include the baseline for humans. And so one of the things that we found was most of the AI struggled with answering questions related to data visualization. So that's like the number one finding. The second finding that was most important is that of all of the AI models, Claude actually was the best of all when it came to understanding data visualization. But these results like isn't necessarily across the board. The results depend on the type of chart, and it also depend on the specific types of task within that chart. So I would definitely be cautious with the use of AI. They definitely do not exceed a human's performance in most of the cases. Uh, except like there are some outliers here, but in most of the cases, human performance is as good as or better than AI with reading and understanding data visualization. So we should definitely practice some caution when we're using these tools. But this is the worst that AI can do. So it's only improving and it's only getting better. So I'm really excited to see what the future holds in regard to uh, the data visualization literacy of these AI tools, but then also what the future holds in our ability to document data visualization literacy and also use that as evidence to improve data visualization literacy across the United States, but also across the world. So, uh, with that, I'm happy to answer questions. My goal was to do like 40-minute talk and then more questions. So I think we're on time.
Excellent. For everyone in the audience, please raise your hand if you'd like to speak or put your question in the chat. We already have one. Alvita, it's are these error rates then? So 0% error versus 100% error?
Was that with
The last visualize the comparisons with AI, I believe, is what that's related to. And Marina, if you want to come off mute and ask your question
yes,
in
I was
more
gonna say that.
detail.
Yeah, thank you for taking the question. Super interesting talk. I have a question around reading the slide on AI. I thought it was really interesting. When I
Okay.
saw the tree map that you pointed to specifically, my takeaway would have been that Claude performed the worst because the accuracy was the lowest. But you
Oh,
said that
yes.
Claude performed the
Yes.
best.
So overall, Claude was the best. So if we look at just average scores, if we average the performance overall, you can see, for instance, Claude is outperforming here,
Uh,
here, here,
got
here.
it.
So when we average overall, if we compare Claude to the other AI models, it performed best. But the performance depends on the specific type of chart and also the specific task, even within a chart.
Okay, awesome. Thank you so much.
Of course.
Okay, can you go back to an early slide where you showed an article on data visualization? One of our participants would like to see that again.
Which article?
She thinks the first author's name was Katie,
Okay.
potentially.
Um, so this was the one where they collected data in museums. This is Katie Bonner. Uh, this one. So
Is that right,
investigating
Kim?
aspects.
Kim, you're welcome. Okay, she said yes. That's exactly right.
Okay, so investigating aspects of data visualization literacy using 20 information visualizations and 273. Gosh, this isn't the title is, yeah.
All right. Other questions for Alvita? Alvita, I'll ask you, what did you initially when you were making the observation that visualizations are intuitive for people, but also literacy is much lower than we think? Like, what were your initial thoughts about that?
So one, I was actually pretty fascinated to see that the children were able to just create visualizations into it. I didn't expect that at all. I actually didn't know what to expect going in. So that was fascinating. But then that actually calls into question, and I do have lots of questions about just the effectiveness of these standardized tests. One, like they are maybe necessary just because it's an easy and effective way just to collect data from lots of different people. And then it's easy to compare it because it's standardized. But it could also be that these tests might not necessarily be reflective of like it's not a universal measure of visualization literacy. So I don't think it's a solution for everything. But I also wonder if there are now also some design issues in how we create data visualizations. Because if they're so intuitive that people are creating them on their own, then they should be able to understand them. And so that could mean that we need to rethink how we design visualizations and design them based on how people think about data and how people intuitively create these visualizations. Uh, I don't know how to do that well. That's like a call for the community, but it would require more of us actually going out into the public and talking to people. You'd be surprised that there isn't a lot of research that actually goes out into the community. I can think of maybe like a handful of work in the visualization community that actually went out either to like a farmer's market uh, or to a museum. We don't see that at all.
I agree. I actually found that interesting about the visualization contest yesterday. Being able to look at the posters with other people and talk about what was intuitive and what wasn't.
Yeah.
So that was an exciting part of the week. I have another question while we're waiting for our audience to find theirs. When you were testing on the AI versus human visualizations, did you use both poorly made visualizations and well-made visualizations?
No, I did not. Oh, actually, I'll see if I can like pull up some uh, data on the fly. So actually, yes, we did. So I didn't present some of the data that we have. I only wanted to give a brief overview. But we did use a test called Calvi. And I don't know if you recall earlier, I talked about people now starting to expand the definition of visualization literacy to include whether or not people can detect misleading visualizations. And so, yes, we used and I'm gonna like share my screen now. So you're seeing like things that are hot off the press. So this hasn't been published yet. It has been accepted, but isn't officially published. And so in this test called Calvi, we looked at different examples of issues with visualization. So for instance, there's some visualizations that had overplotting. So this is imagine a scatter plot with a lot of dots. And so you can't see all of the data. There are some where the data wasn't normalized. There are some visualization where some of the data was missing. Some of them had misleading annotations. Some of them had in unconventional scale directions. So instead of the y-axis going up, it might be going down. The data was improperly ordered. So that is similar to the chart that I started out with from the state of Georgia. There were issues with the scale or issues with the range. There were issues where the author of the visualization may have cherry-picked some of the data. Some of them were concealing uncertainty and so forth. And so, yes, we did that. The main thing that we found was that well, humans are also bad at this, just to say that. But there are lots of examples where the AI struggled with identifying misleading visualizations. So this is something that both humans and AI continue to struggle with. And uh, one of the most recent work, though, that I saw, this may be able to be corrected through prompt engineering. And so if you explicitly tell the AI to look for misleading stuff, it likely will find it. But I think that's the case for a human as well. If you say this chart is misleading, find what's misleading. But if that wasn't prompted, then AI definitely struggle with identifying misleading visualizations.
That's so interesting. Okay, I have Kim next, and then after Kim, Todd has a question. And then we'll have Andy's question. We'll do it in that order. Go ahead, Kim.
Um, I was wondering if, and forgive me if it's very obvious and I missed this, but are anthropologists or philosophers or other people in the social sciences involved in your study? I see that there's a lot of great computer science background, but it just sounds so interdisciplinary, the work that you're doing. I wonder if others are involved. And I really appreciate this talk because this is my first year doing Love Data Week. And this talk is indeed unique to all the others I've seen. So thank you.
Thanks, Kim. Short answer is no. And I think that is something that I noticed to be an issue. Uh, Going back to 2020, I was a part of a workshop that was organized by anthropologists, and it was fascinating to see how they were critiquing visualizations that were very popular at the time, and also visualizations that were uh, popular in the research community. And so, short answer, no, but longer answer is I do think that's a flaw in a lot of research that we do. Generally speaking, my work is I try to involve people from different communities. So I collaborate a lot with folks in psychology, or I've been collaborating with designers or even economists recently in terms of how do you evaluate them. But yeah, I do think I would love to talk to more anthropologists because it's pretty insightful to see a different perspective of how people think about data, but then also how people think about the use of these tools and how they impact society. But short answer, no. Long answer, I would love to see more anthropologists being involved.
Yeah, that could be really interesting, using their ethnographic sort of methods, which
Yeah.
I assume maybe Kim would love to talk more about. Todd, go ahead.
Thank you. And thank you for the presentation. It is great to see this. I I wondered, I mean, you can't go online. I mean, you can find online about 1 million lists that are called things like 8 best practices of data visualization or here's what not to do. And most of these come from statisticians or psychologists, and I think that their intended audience really is other people like them.
Yes.
So I appreciate that you are looking and getting feedback from from more types of people. Uh, is, do you uh, like Jennifer's question about can can AI see things that are wrong with it, or like bad graphs and good graphs? Like if they were intentionally sort of sorry, if they were intentionally sort of trying to mislead people or not. Uh, Similar to my question, but my question is like, are there, have you found different types of charts, more people are familiar with one type of chart versus all these other charts, or that there are a whole family of charts that people really aren't familiar with? Uh,
Um,
and then,
yes. Uh-huh.
sorry, and
Go ahead.
then just to finish, my one example is that uh, I think there were a handful of articles in the 80s or 90s about pie charts. I'm sure that a lot of people have heard of it, that pie charts are the worst type of chart ever. And you can pick randomly any two statisticians and they'll still argue about it today.
Yep.
So, so that's where my question is coming from.
So yes, lots of different thoughts here. You're definitely right about, let's start with the pie chart thing. That was surprisingly still somewhat controversial, even though in the research community, we've kind of like tamped down on that argument a bit. Yes, pie charts are, people struggle with more with pie charts than with bar charts. So there is, for those who don't know, there is a class of people who think pie charts are bad and you should never use them, particularly because there were some low-level perceptual studies that show that people are better at judging height in bar charts than they are with judging angles or proportion of a pie chart. The problem with that prior work, though, is the specific task that they use. So the task was uh, what percentage of this slice of pie is of another slice of pie. And so they would compare people's performance when they asked that in terms of a bar. What percentage of this bar, smaller bar, is of this bigger bar? But the main critique of that prior work is that when you use pie chart, you're not using it for that task. You're using it for like a part to whole comparison. So you want to know of the entire slice of pie, like what percentage does something make up of an entire slice? And so what prior work has shown, or more recent work has shown, is that when it comes to part to whole comparisons, pie charts are actually even as good as, or sometimes superior to bar charts with that specific type of task. And then there are also these issues where, well, not really issues, but just acknowledging that there are some benefits to pie charts because of the anchoring effect. People are very familiar with the clock as like telling time. And so a quarter is something that people can easily recognize, or half of a pie is something that people can easily recognize. And so in those types of instances, pie charts are valid. And so I think we don't see like people like trying to die on the hill of pie charts of bad anymore, but that was definitely one of the things that that people tend to focus on a lot. In terms of the other part of the question with regard to familiarity, we do see that there are some charts that are more familiar than others. I'm going to show different uh, a different. So this is, I'm going to walk through this. So this is the different types of charts, tree map, stacked bar, and this is a score where we surveyed people to see how familiar these charts are. And this is the same project where we collected data from Australia, Chile, Israel, and so forth. You can easily see here that in terms of familiarity, the pie charts were pretty familiar to lots of people, and bar charts were line charts. So these were the charts that were pretty familiar. The tree map, which is, let's see if I can find the tree map. Oh, okay, it's not in here. Uh, it's 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 like boxes inside of boxes inside of boxes that tended to be unfamiliar. And a bubble chart was also pretty unfamiliar. And that was, it's a, imagine a scatter plot, but with their different circles on the scatter plot, like with different sizes. So yes, there are different charts uh, that are more familiar than others. And that familiarity also depends on the person, depends on the where they're from, their cultural differences in chart familiarity, as you would expect. Yeah.
Thank you.
Okay, we have two remaining questions. I'm going to read them both to you, and if you can address them both in the next, 6 minutes, you're welcome to, or you can choose one. So one is, I didn't see any Gantt or Venn diagram visualizations. Were those used as well? I think those were new to me later in my life, post high school. And then the other question is, have you or others explored fine-tuning any of the popular LLM interfaces for improved AI visualization literacy? Alternatively, have you or others in this space explored building an AI model chatbot specifically to help people understand data visualizations?
Those are some really good questions. First, so one of the biggest critique of a lot of the existing tests out there for visualization literacy is that they're not comprehensive. So that is that's a really good observation. So it didn't include Gantt charts. It didn't include like what do you call those kind of charts as well? Box plots. Like one of the most popular charts that we see, especially with like health communication, this icon diagrams. So that wasn't included. So that is definitely a critique that I see often, that these charts are not represented. However, there is some work where people have been trying to develop tests for specific types of charts. So they could be a visualization literacy test for line charts, or a visualization literacy test for insert chart here. Uh, it's it's definitely work that has to be done. So with our specific work, we've just been focusing on what is a short test that we can do that could be predictive for a lot of different things. And so we're looking at how predictive it is and so we're expanding the task that we're looking at. But I do think you're right. There is a lot of space for thinking about more specialized tests, but also maybe more comprehensive tests. But it's always a trade-off. The more comprehensive it is, the more time it would take to do. And yeah, there are lots of considerations there. In terms of customizing AI, yes, so I agree in that there is a lot of opportunity for us to, instead of using these general purpose AIs for creating for instead of using general purpose AI that is not necessarily trained on data visualization and expecting them to be good at data visualization, one thing we can do is like create something that is more specialized. There have been people looking into that, but the biggest problem that we have is the available data sets. They need to be trained on something. And one of the things that we are lacking is large scale data sets that have both good and bad visualization design. So that is something that I think is feasible, but we will first need to collect that data set. And that is actually not necessarily, it's not a trivial task, but I do think that it can be done. And there are people who are thinking about that as well, particularly people at Microsoft Research. They're looking into that right now. Jennifer, you're muted.
All right. So that is the end of the questions. There are a few comments about how super interesting and valuable this presentation was, and hoping that we'll be sharing links and things after this. So we will be sharing the recording. I don't know, you're not sharing your slides, are you,
I
Alvita?
can share my slides if that will be
Okay,
helpful.
and then the slides too. So we will provide both of those to everyone who's registered.
Yeah, thank you, and happy Valentine's Day to everyone.
Yeah, happy Valentine's Day. Thank you so much, Alvita. This was amazing, wonderful presentation.
Thank you for having me.
Yeah.
Yep.
Yeah.
All right. Goodbye, everyone.